Day 11. Have starting item. Oh. Okay. It's active. I need to like read this actual. Okay. Starting item. Okay, fine. Two. 605. No. Hmm. It doesn't matter. Okay. Let's see. Okay. Uh, Fine. That was pretty close to being good because I spent a long time debugging this stupid error. Oh well. So what was going on here? This was kind of involved. I'm a little surprised people solved it so fast, I think. How do I modify this code to work with both part 1 and part 2? do like that. Six, correct. 975 4 71646. Okay, cool. So now this follows part 1 and part 2. So what is going on? So I mean, basically we're just following the instructions. And then there's one tricky thing for part 2. So the first thing to do is just to parse, the input, which is, and maybe this should be like a data class or something. But anyway, a list of items for each monkey, the function that they perform, which actually I did something kind of clever here, maybe, which is just like take the string as a Python function. Which monkey to throw it to, the test, which is always divisible by some number, so what number you're trying to divide by, what to throw it if that's true, what to throw it if that's false. So we can grab the list of starting items by just taking this and splitting on commas. The function, we can grab the last 3 words and eval it as a Python function. This is, kind of, I don't know. We could also, I don't know, sort of more manually parse it if we wanted to be less fancy, but it's a cool way to do it. And these ones are simpler. We just take the last thing from each line, and that's the number that you divide by, and the monkey that you throw it to if it's true, and the monkey that it's false. Okay, so once you've done all that parsing, you basically just like do the process. So in part 1, 20 times you go through each monkey, you apply its function, you divide it, integer divided by 3, and then, do the test. If it's true, so add it to this list. If it's false, add it to this list. And then you can empty out your own list because you processed all your items. And then you just print out, so you can also keep track of how many times each monkey touched an item, and then print out the highest 2 from that list. And then in part 2, we're supposed to do 10,000 rounds, and also we skipped the divide by 3. So the problem with part 2 is that the numbers get very big, and so it would just take ages to like compute the rounds. So the insight here is that we don't really care about the full number. We just care about how the number is mod, all these things. And so if we we just need to keep track of the number modulo like the product of all those things, or actually the least common multiple of all those things. I mean, the product would probably work fine as well, honestly. Well, I don't know. That's a that's a fairly big number. So dividing by the GCD is probably pretty helpful. It's not at all helpful. Okay, yes. Oh, okay. I do need to do this. Yeah, so fine, that takes like 3 seconds. And if I do it this way, also 3 seconds. Okay, so you don't actually need the GCD. In fact, it doesn't do anything. Anyway, but you do need the mod. So what is the point here? Example, I guess 23, 19, 13, and 17, which are all primes, so I guess that's why the GC didn't do it. Right, so the reason for that is that like so basically like we can just subtract off all of the 23 a bunch from each of the items until we get, sorry, I mean that's what mod means, right? Is to take the remainder when you divide by 23. And basically the point is that mod respects multiplication and addition, right? That is like x plus a is divisible by 23 if and only if x mod 23 plus a is divisible by 23. X times a is divisible by 23 if and only if x times 20 mod 23 times a is divisible by 23. I don't know. I feel like I'm not explaining this very well. But anyway, you can just reduce all of the items mod the thing that you're trying to keep track of, the divisor. But actually, we want to keep track of whether it divides like this whole list of numbers. And so we can keep track of the number modulo the product of the entire list. And that's basically for a similar reason, right? For a similar reason as you can like subtract out 23s here, you can also subtract out any multiple of 23. And so you want to keep track of it, keep track of whether or not it's divisible by 23. You can subtract out any multiple of 23, keep track of whether or not it's 19, subtract out any multiple of 19. So you can subtract, like this number is a multiple of all of these numbers. And so you're allowed to subtract it, and it won't break any of your divisibilities that you care about. And yeah, I thought this would be, you get a smaller number if you divide it by the GCD, which is like also still a multiple of all these numbers, but they're all like prime input for some reason. So that trick is not helpful. I guess maybe because Eric did not want people to need to know about that trick. So anyway, in part 2, we can compute this product, which is it's a big number, but it's not quite a big number. It's not. It still helps to keep them bounded though, because if you just let the numbers get like infinitely big, it just takes forever to do math on them. Especially like whatever monkey is squaring the numbers, that's gonna like double the length of the number every time, and so you're just never gonna get through 10,000 rounds. But even though this number is pretty long, it's like, I don't know, 100 digits or something. You know, it's still manageable. 274 digits. Jeez. Well, good luck doing this problem in C++. Yeah, so I mean that's basically just the only trick for part 2 is you don't do this thing, and then you do need to do this modulo CM. And otherwise, it's just the same, except you do 10,000 rounds and print out the largest two things. And this is surprisingly fast. I mean, I guess it's not that surprising because there's only however many items there are, like probably a few dozen items or something, and they each get thrown 10,000 times. So each item gets thrown once in each round. So that's not actually necessarily true, but like at most 8 times, right? It gets the monkey, throws each item at most once in each round. You can imagine like monkey 0 throws everything to monkey 1, throws everything to monkey 2. Obviously, that's not actually what happens. So it's reasonably fast. Okay, in fact, let me just compute how fast. So in part 1, we throw 1,608 items, and in part 2, we throw 702,000 items, which is, would be a lot if we would like keep track of it by hand, but 700,000 is a small number for a computer. A computer can do like roughly 1 billion operations per second. Okay, yeah, that is all I have to say about this problem. See you tomorrow.